So, welcome to tutorial number 4 QE, question number E here. So, here two streams of steam at 0.8 MPa are mixed adiabatically, and after mixing the enthalpy H is equal to 2789.61 kilojoule per kg. Calculate the degree of superheat. So, in this problem lot of data has been given inherent in this problem itself. First, both the streams are at 0.8 MPa, that means the mixture also will be at 0.8 MPa, that is one thing. Second thing is, when I am saying that calculate the degree of superheat, it also means that this is in a superheated region. And what is the degree of superheat? I will just show you, but two answers are hidden over here, that the pressure of the mixture is given, at the same time the enthalpy has been given. Till now we have had pressure and temperatures, pressure and let us say dryness fraction, but here we have got the pressure and enthalpy as the data, and therefore this problem is little different than what we have done till now. So, question E, we got a mixture at 0.8 MPa, that is the pressure, and corresponding to that what has been given is enthalpy H is equal to 2789.61 kilojoule per kg. Now, what we can do is we have to compare in which zone it is, although I said that we know the region, but let us find out from the table. So, at 0.8 MPa, let us find out what are the HF and Hg respectively. Alright. So, I will refer to table number 3, because from table number 3 also I get these values. I can get these values of HF and Hg from even table number 2 also, where the pressure is the base, but I will go to table number 3 and open the page for 0.8 MPa, and from that let us get the value of HF and Hg. Okay. So, let us go to table 3. So, this is table 3 at 0.8 MPa, and correspondingly you can see that the Tsat values have been given 170.406. So, I can go to this Tsat value, and corresponding to this Tsat value I can get HF and Hg values. So, let us see this 170 degree centigrade. You can see here the property is given above this line which separates the liquid region and the vapor region. So, here we can see that these are all my Vf, Uf, Hf, Sf values, while the one which are below are Vg, Ug, Hg and Sg value. Right now we are interested in the values related to enthalpy only. So, I can conclude from here that Hf is equal to 720.86 while Hg is equal to 2768.3. I will just note these values and we can then come back to our problem. So, corresponding to Tsat value, just note the HF and Hg values from this table. So, HF is equal to 720.86 kilojoule per kg and Hg is equal to 2768.3 kilojoule per kg, and corresponding to this I got Tsat is equal to 170.4 degree centigrade. Obviously, we can see that our H value, which is 2789, H is equal to 2789. So, I can say that H is more than Hg. The moment I say H is more than Hg, I am sure that I am in a superheated zone, superheated vapor zone. Now, the question is the degree of superheat. So, degree of superheat is nothing but the temperature of this mixture minus Tsat value, alright. So, Tsat value we already know, Tsat is equal to 170.4 degree centigrade. So, what I have to find out is at H is equal to 2789, what is the value of T? that is what we want to see. So, what we know is H, and what we also know is P is equal to 0.8 MPa. So, we can again refer to the same table, table number 3, and see the value of H now 2789, and corresponding to 2789, look at the value of temperature. If I see the value of enthalpy, this is the value of enthalpy, and what we want is 2789. So, we can see that I can go down and come back to somewhere here. 2789 falls between, this is 2780 and this is 2792. So, the value of 2789 can be interpolated here between these two temperatures, 175 degree centigrade and 180 degree centigrade. So, if I do proper interpolation now, I can calculate this value is equal to 178.875. So, after interpolation, I found out this temperature is equal to 178.87 degree centigrade, and therefore, degree of superheat is equal to T minus T sat is equal to 178.87 minus 170.406 is equal to 8.415 degree centigrade. So, this is the answer. Degree of superheat for this is 8.4 degree centigrade. I hope the concept is clear, and degree of superheat I may not have taken the theory, but it is a simple thing, the temperature T minus T sat value corresponding to that pressure. So, I can write down the answer now here. The degree of superheat is found to be 8.415 degree centigrade. Thank you very much.